I'm going to do one more right triangle example, and you'll be glad that we're doing this because it's a lot like one of the harder problems on the assignment. And it also kind of gets you to think about a couple different things going on in one problem. Maybe I should have encouraged you. Do you want to find that PDF from yesterday? I have like some of the bits and pieces from the PDF, but the PDF kind of on Google Classroom kind of shows you the information. You might want to pull that back up to make this a little more worthwhile. It's the third example on that, again, that little PDF. Okay, now what we're trying to do is we're trying to find the height of the flagpole. But you're going to find out that it uses a couple steps, and it actually uses a couple triangles very carefully to do that. If you're not able to pull up that PDF, I do have like the bullet points, but it's always helpful to read it so you're not just kind of waiting or depending on me too much. Just like yesterday, and I encourage you to follow along one more time here. In your notes, make a sketch. Okay, I'll kind of help you with that, but you have to be able to kind of draw some simple illustrations of what is being talked about here. I'll kind of help you to simplify it. You don't want to overcomplicate your sketches. Basically, we have a building, and on top of that building, we have a flag. Okay, kind of the typical school-looking building, although most of the time the flag's not just stuck on top anymore. Now, there's some information given. Okay, basically, you are standing out here. Now, it doesn't say anything about height, eye level. Okay, so since it doesn't say anything about eye level, you can kind of simplify this problem to just basically be an eyeball that's, I guess, on the ground. But it does say that the angle of elevation to the top of the pole is 65. Okay, so this big old angle right here is 65. And this is really why we're going over this problem, there is this implication that there's another triangle, basically another angle, because when you look just to the top of the school building, that's only going to be 50. It's only going to be 50. Now, what you have to be able to see in a problem like this, and you'll see a few of these in your assignment, is the ability to see two triangles. Both of them share a side. Okay, so there's two triangles. You might be able to kind of highlight the one that's kind of in yellow, and that triangle, it has a side of 25, and of course it has an angle of 50. And then you have the second triangle. The second triangle is kind of that original one that I drew, the larger white triangle. Okay, and what you don't want to do is you don't want to get carried away with this triangle right here. I almost hate to show it, but honestly, this triangle right here is not going to help us. For one reason, it's not a right triangle, and the second reason is you don't know any dimension. Like you don't know a side. You could be able to deduce this angle right here is 15 degrees, but it's not helpful because we don't know a side. So you want to get your eyes to not see things that aren't right. Okay, no pun intended, but aren't right, like a right triangle. Let's focus on the yellow one, basically finding X, maybe like the height of the school building. So the school building, okay, so Again, not to state the obvious, but it's going to use 50. It's going to use 25. We got to do a little bit of thinking about SOHCAHTOA. Okay, this side over here, I hope you would say is the opposite, but this side has always been the adjacent. It's adjacent to this angle. Okay, so we've got an opposite and adjacent. Perfect example, tangent. Be careful that you also don't accidentally plug an angle in for a distance, or vice versa, a distance in for an angle. I have to confess, I almost did that as I was writing these numbers down. So 50 degrees obviously goes with tangent, 25 is the denominator. I hope that you're playing along on your calculator. You're just going to multiply, right? You're just going to multiply by 25, and you get 29. Okay, so that's like the height of the school building. Do you realize that the large white triangle is also has a side that we can find, but you have to realize that we're finding like that whole side. Okay, it's honestly the only other thing that we can do here. I'm just going to call this like the overall height. Please don't confuse that we're actually finding right now just the flagpole. Okay, we're not ready for that. We're finding the overall height because we're focused on a right triangle, and that right triangle has a new angle, but it has the same side. It has the same 25. Okay, so if you're playing along, you can multiply by 25, and even the answer you get when I say it should make sense that it's bigger. It's bigger. In fact, as you look at your two answers, you can kind of hopefully see how the one that's bigger and the one that's smaller can give us the space that we seek. It can give us the height of that flagpole. And so this problem has just that one more simple step. Of course, that idea of subtracting those two numbers. Now, the way that I kind of modeled this for you, do the same thing in your assignment. Show the work, okay? Show the setup. Don't just magically write down an answer. For a problem like this, it's not magical when we get this answer. You have to do some math so that you can subtract those two numbers. So it looks like the flagpole, for whatever reason, is 23.82 feet. But it works with the numbers that we got. Okay, now in the assignment, those of you that have already started, you kind of realize this, but expect to find some different questions. Like, not everything's going to be like the three that I did on the board, but the ideas I showed you on the board, you can kind of apply. In other words, you don't have to go searching for some new math. Okay, you just have to apply the math that I've given you here. Okay, so it's a work period for you.